Derivation of expression of distance travel in tth second using integration. Prove that the distance traveled by a body, in tth second is s subscript t is equal u plus half a 2t minus 1 using integration, using the concept of calculus, that is the using the concept of integration. This is a straight line along which a body will be moving. Initially the body was at the point A and was moving with initial velocity u, and this point, the point C, is the final point at which the body has the velocity v. At A t equal to 0 and at the point C t equal to t second. At A v velocity v was u and at the point C velocity v becomes v. Now we consider a point B at which time t is equal to t minus 1 second. At the point B the body is moving with velocity v prime, and at A s equal to 0, at B the displacement s is equal to s prime, and at C the distance s is equal to s, total distance s. At B the distance is s prime and at C the distance is s. Now the distance traveled by the body from A to C, the distance traveled by the body from A to C is s, and the distance traveled by the body from A to B is s prime. S is the distance traveled by the body in t second and s prime is the distance traveled by the body in t minus 1 second. Now we can denote st, that is the distance traveled in tth second. St is the distance traveled by the body in tth second, that is in last 1 second between B and C. Now the instantaneous velocity of a body, is given by v equal to ds by dt. Therefore ds is equal to v dt equal u plus at into dt. Since v equal u plus at, we get ds as equal u plus at bracket closed into dt. ds is the small change in displacement of the body. Integrating both sides we get integration ds is equal to integration u plus at dt. Integration s prime to s ds is equal to integration t minus 1 to t u plus at dt, or comma under third bracket s prime to s integration u dt t minus 1 to t second plus integration at dt t minus 1 second to t second, or comma putting the upper limit and lower limit we get s minus s prime, bringing u outside integration u integration dt t minus 1 to t second, plus bringing the acceleration a outside integration we get a integration t dt t minus 1 second to t second, or comma in place of s minus s prime we can write st, that is the distance traveled by the body in tth second. In the diagram we have s and s prime, and s and s prime is equal to st. St is the distance traveled by the body in tth second, that is in last 1 second, and it is derived. It will be obtained by subtracting s prime from s, that is by subtracting the distance traveled by the body in t minus 1 second from distance traveled by the body in t second, and we get u third bracket t minus 1 to t plus a third bracket t square by 2 t minus 1 to t second, or comma st equal u, putting the upper limit t and lower limit t minus 1 in place of t, we get u t minus 1 putting the upper limit t in place of t, then lower limit t minus 1 second in place of t, we get t minus bracket open t minus 1 plus a bracket open t square by 2 minus t minus 1 whole square by 2 or comma st equal u into t minus t plus 1 plus a, doing LCM we get t square minus t minus 1 whole square whole divided by 2 or comma st is equal u into 1 plus half a under bracket t square minus t minus 1 whole square, or in place of t minus 1 whole square we can write t square minus 2t plus 1 or comma st equal u plus half a, st equal u plus half a t square minus t square plus 2t minus 1. Therefore st is equal u plus half a 2t minus 1. st is equal to u plus half a 2t minus 1. That is the distance traveled by the body in tth second, and hence it is proved st is equal u plus half a 2t minus 1. That is the distance. This is the distance traveled by the body in last 1 second. That is distance traveled in tth second. Distance traveled in tth second. st is equal to u plus half a 2t minus 1, which is the distance traveled in tth second. That is the distance traveled by the body in last 1 second. We get st as equal u plus half a 2t minus 1. Now we can compare the expression of distance traveled by the body in t second and distance traveled by the body in tth second. S equal ut plus half a t square, and right hand side we can write st as equal u plus half a 2t minus 1. S equal ut plus half a t square, that is the distance traveled by the body in total t second. Distance traveled in t second. On the right hand side we can write st as equal, u plus half a 2t minus 1. st is equal u plus half a 2t minus 1, which is the distance traveled in last 1 second. That is distance traveled in tth second. In last 1 second means in tth second. st is equal u plus half a 2t minus 1, which is the distance traveled in last 1 second. Dimension of s is equal to dimension of l, but on the right hand side dimension of st is equal to l t inverse. That means st will have the dimension same as that of the velocity of the body.